Hello and welcome to this new multi-part video series on vector analysis. This is an important topic and very useful in many practical applications. We will start with the basics and build on this slowly. Each video will contain examples and explain the solution using codes written in Python programming. So let's start learning. So what are scalars and vector quantities? Scalar quantities have magnitudes but no direction. Examples of scalar quantities include temperature and time. Vectors, on the other hand, have both magnitude and direction. For example, force, displacement, velocity, and acceleration. Let's say we are sitting in a car and drive in the north direction with a speed of 100 kilometers per hour and cover a distance of 60 kilometers. Then we drive in the east direction with a speed of 80 kilometers per hour and cover 100 kilometers. What will be the final position or the resultant displacement of the car with respect to the starting point? We can represent it with a vector r where I hat and j hat are the unit vectors in the east and north direction, and the vector r is also called a resultant vector. For any non-zero vector a, the unit vector represented by a hat is the vector divided by its magnitude. It has the same direction as the vector a. In real-world applications, we frequently use the rectangular coordinate system. The unit vectors corresponding to the x, y, and z directions are I hat, j hat, and k hat respectively. Let's say we have an arbitrary vector a in this coordinate system. Then we can view this in terms of distance as we started from origin covering ax distance in the x direction, then ay distance in the y direction, and then az distance in the z direction. We can also see that the product of the distance in the x direction, that is ax, with the I hat unit vector outputs another scaled vector. And as we saw in the example from the previous slide, we can write the resultant vector A as a sum of its component vectors, which are AXI, AYJ hat, and AZK hat. AX, AY, and AZ are called components of the vector A. The magnitude of this vector is then the square root of the sum of the squared components. As the name specifies, the unit vector has a magnitude of 1. Let's see how we can plot a two-dimensional vector using Python programming. We write a function which takes the terminal point and the initial point of the vector as arguments. If only the terminal point is provided by the user, then an initial point at 0, 0 is assumed. Then we use arrow method from matplotlib to plot the vector. We provide the starting x and y and the differences between the terminal point and the initial point, which are dx and dy. For example, if we want to plot three vectors 1 0, 0 1, and 1 1, we'll simply need to call plot vector 2D function, and we can see a plot of the vectors. It is easy to notice that C is the sum of the vector A and B. That is, this is the resultant vector. Let's try to solve a problem in which we want to find the unit vector for the vector A, which is equal to 2 times I hat plus 3 times j hat. As we saw before, that to compute the unit vector, we need to divide the vector by its magnitude. So let's first write a function to compute the magnitude of the vector. Then we compute the unit vector, and then call these functions to compute the unit vector for the given vector A. We can also confirm that the magnitude of the unit vector is 1. which comes from the output of the print statement on line 8. If we have two vectors a and b, their sum will be simply the sum of their corresponding components. We use the add underscore vectors function to add these two vectors. We have written a separate function to compute the difference between terminal and initial points. Once we compute these differences, the vector addition is simply achieved by element-wise sum of the two arrays dp1 and dp2. In another example, where initial point of the b vector starts at the terminal point of vector a, the resultant vector is the same as vector b in the previous example. Similar to vector addition, the difference of two vectors a and b will simply be the difference of their corresponding components. For this, we use the function subtract underscore vectors. We can then call this function and solve the vector subtraction problem. When a vector is multiplied by a scalar, it scales accordingly. If the scalar is positive, the direction of the output vector remains the same as the input vector. A negative scalar, however, changes the direction of the output vector. We use this function scalar underscore vector underscore multiplication and find the product of scalar m and the given vector a. In another example, where the initial point is not at the origin, for the same value of m, we stretch the length twice the original length of the input vector in the same direction. With this, we conclude our video. In the next video, we'll learn more exciting topics with more examples using Python programming. Please subscribe to my channel for more videos like this. Thanks for watching and see you in the next video.